As I say, this information has been around now probably 100 years. These particular curves here are fatigue curves. There's two types of materials we're talking about here. One is our steels, our ferrous alloys, which are the A curve. Then the non-ferrous, things like brasses and bronzes and aluminiums would be the longer curve. Interesting things when we have a look at what this curve is, and I learnt this in my university course. One of the things that mechanical engineers learn is this particular information here. It wasn't until I began looking for why things fail and trying to understand the science of failure that I went back to this particular curve, and it began to tell me a different story that I never saw before as a new engineer. What this curve says, so we take curve A here, curve A, says here at very high stress, and this particular stress is the stress that fails our equipment. At very high stress, we don't last very long. Here you've got 10,000 cycles. But as the stress comes down, if I halve that stress, now I've got 1,000,000 cycles. So what this curve says, if I want to have long life, if I want to go from 10,000 cycles to 1,000,000 cycles to 10 million cycles to 1 billion cycles, then what I've got to do is bring the stress down from my parts. If I reduce the stress, then I get reliability, because 10,000 to 1,000,000, I have made the plant reliable. I've got 100,000 more cycles there. Now with steels, it's interesting as well. Once I go below this threshold, this line here, once I go below that line there, it is infinite life on materials, on ferrous-based alloys. So the story is the same. If I want to have long service life of machines made of ferrous-based alloys, then I should be down in this zone here. I should be underneath this line here of infinite life. And when it comes to our bearings, top quality bearings, the designers of bearings actually design in this zone here. So bearings should last decades. Long time trouble-free, because that's what it's designed to do. So if our bearings are failing very early, as in a matter of weeks and months and even just a few years, what must be happening is they must be being driven up this curve here, because they're failing at sooner time than they should have failed. So when it comes to mechanical failure of our parts, then this curve plays a big part in why things are happening. They're designed to last a long time. They're lasting a short time. They must be being forced up this curve. And of course, life is being reduced. And the same with curve B, other alloys, other materials. This, of course, eventually goes to zero. So those parts, in time, will need replacement. But the story is the same. I reduce the stress, lower and lower and lower, the longer and longer my parts last. So if I can manage stress, then I have a way of controlling the reliability. And that's a big factor when it comes to the techniques we use in plant wellness. One of the techniques we use is precision maintenance. And that's about ensuring things are perfectly aligned, perfectly positioned, perfectly run to make sure we get the maximum service life before any problems begin to accumulate.